Right, we're interested in finding all solutions to the equation. And to do that, we note that we've been given z to the power 3 out of 2 minus 1 minus I equals 0. This implies that z to the power 3 over 2 is equal to 1 plus I. But we know that 1 plus I has modulus the square root of 2 into the cosine of, okay? 1 plus I has the argument pi over 4 radians, the sine of pi over 4 radians, like so. Okay, what do we then do? From this point onwards, we solve for z, obtaining z equals, now the square root of 2 can be written as 1/2, 2 to the power 1/2, and then you raise it to the power 2/3, cosine of pi over 4. Now we can write here pi over 4, we add 2 pi k, we multiply by 2/3. So we have this. We have exactly that one. So we can write here the cosine, and we close the parenthesis like so. We add to this I the trigonometric sine of pi over 4 plus 2 pi k, which is 2 over 3. We close the parentheses that way. Right, realizing that the 3 in the denominator of the fraction here says this is true for k equals 0, 1, then 2. What happens for k equals 0? We investigate. Because this becomes the cube root. Right, so here 2 cancels, giving us 2 to the power 1/3. Into, simplifying the inside gives us exactly the trigonometric cosine of pi over 6 plus I, the sine of pi over 6. Okay, so which is 2 to the power 1 over 3 into, now the pi over 6 becomes exactly the square root of 3 over 2 plus I over 2, which is 2 to the power minus 2 over 3, the square root of 3 plus I. Now for k equals 1, is z to the power 2, which is 1 over 3 cosine of. Right, if you put k equals 1, then this becomes exactly 9 pi out of 6 plus I, the trigonometric sine of 9 pi out of 6. Okay. And if you simplify these here, it is the same as what? Right, so the 9 pi over 6 simplifies to 2 to the power 1 over 3 into the cosine of 3 pi out of 2 plus I, the sine of 3 pi out of 2. In which case, therefore, this is a -1. Minus 2 to the power 1 out of 3. We continue to investigate these for other values of k, like for k equals 2. For k equals 2. Giving us that equals 2 to the power 1 over 3 into the cosine of 17 pi out of 6 plus I, the sine of 17 pi out of 6. Okay. And what we're then getting out of this is pretty interesting, because this is exactly the same as 2 to the power 1 out of 3 into minus the square root of 3 out of 2 plus I out of 2. Upon further simplification, this is 2 to the power minus 2 out of 3 into minus the square root of 3 plus I. Like so. And therefore, this becomes the result. And we had to find the solutions to this particular equation, and we have been able to find the solutions to this equation. Just to mention, in passing here, something short and brief, that the complex number 1 plus I can be positioned in the Argand diagram. And now 1 plus I is sort of here in the first quadrant. And this angle is 1 plus I is actually pi over 4 radians. Pi over 4 radians. This angle here is pi over 4 radians. It's actually pi over 4 radians. That is the size of this argument here of the complex number. And this sits in what we call the Argand, in the Argand diagram. Argand diagram. So, and that is the result. So we are actually done there. And obviously this is the imaginary axis of Z. And this on the horizontal becomes the real axis. Okay, so we have the Argand diagram there. And we are done with the solution to the problem. And we found 3 distinct roots to the problem, because it actually reduces to what you call the cube roots of the complex number there. Okay, thanks everybody. A very goodbye to you.